Hi, everybody. I'm here with Tom Allen, and today we're going to discuss Angona and the formation of Monmatia. Tom Allen is the author of The Great Debate on the Scale of Orvonton. Hi, Tom.
Hey, Josh. What a pleasure to be here with you.
My pleasure to have you. So I understand you studied philosophy.
Well, yeah, I had a religious experience in college and got out of political science and decided to study philosophy. But, I got that degree, but I had found the Urantia book, and so it was time to really delve into that beautiful, beautiful book. And it has changed my life, and I'm sure it has yours.
Yeah, absolutely. Absolutely. So what got you into the scientific topics in the Urantia book?
Well, when I was 12 years old, I grew up in an upper class family. And when I was 12 years old, all of my brothers and sister, when they turned 12, were given the option to have $75 to do anything they wanted with. And this was in 1964. $75 was a lot of money back then. And I wanted a telescope. I wanted a telescope. But do you remember what happened in 1964 in February?
No.
Oh, come on. The Beatles.
Oh.
So instead, I bought a bass guitar.
Nice.
but still, loving astronomy has always been a passion of mine in terms of just wondering what it was all about. But I never pursued it until the Urantia book started intriguing me about it, and I just had to look into it in more depth. And of course, that book you showed about the Great Debate was a culmination of about 10 years of work trying to figure it out. And that book actually is a little bit out of date now. But it has a lot of good stuff in it too. So, but I just love it and thinking about it, researching it, and it's still a passion. It's just a passion. Everybody needs a passion in life, whatever it is. And I think you have one, I have one, and it makes life a joyful thing.
Absolutely. I agree with that 100%. Yeah. This book, The Great Debate on the Scale of Orvonton, I picked it up, I think about 2 years ago, and it was shortly after I picked it up that I reached out to you, and that's kind of how we met and began talking. And we've actually met in person a couple times. Very, very few readers have I actually met in person, so it's nice to have been able to meet you in person, have lunch with you that one day that we met up, and then meet you over at the Orjala's house and got to hang out there. That was a nice experience. So yeah, it's been a pleasure to talk to you about these concepts. And recently you just did that panel on the Urantia Foundation Science Symposium that was on this topic, and or that, not that panel, that a presentation, and I was on the panel to ask questions.
Well, you're the first one to ask.
Well, I appreciate that. I appreciate the opportunity to ask questions. And when I was there, I kind of had a list of questions I wanted to ask, and it seemed like a lot of people beat me to the question, or somewhere in your presentation you answered the question. So when it got down to it, it was like, well, I think all my questions have pretty much kind of been answered. But since then, in hindsight, I go back and I'm like, oh, I wish I would have asked that, or I wish I would have asked that. And so I thought about it, and I was like, well, maybe I should just do a podcast type episode with Tom, and we can kind of talk about it one-on-one. And, so here we are. And that's kind of what inspired this. So I'm thinking, we just kind of dive in, and I really wanted to talk about, paper 57, section 5 is a big part of it. And right before section 5, there's that little section 5748, where it basically talks about like the birth of our sun about 6 billion years ago. That kind of sets the stage for the creation of our solar system as the birth of our sun. So I figured we'd kind of start there. With the birth of our sun is estimated to be about 4.6 billion years, our current science. But I think with some of the stuff that we might talk about today, I think we can kind of show why that is with the Angona incursion, and why the discrepancy of 6 billion to 4.6 billion, which isn't much of a discrepancy, but it kind of makes sense when you think about how they've discovered or how they've came to that conclusion. The 4.6 time frame is based off of meteorites that we found. And once you see like how this has happened through the Angona incursion, you can see how these meteorites are probably closer to the 4.6, but that doesn't mean that's exactly when our sun was born. The story starts off with how our sun early on was highly active variable star. Not like it is today. Like, nowadays we have the 11.5-year sunspot cycle. The Urantia book tells us that in the early days, it was about 3.5 days, not 11.5 years, our variability. So it was a very active, intense star. And we've seen that in a lot of other stars. Science has recently been, since probably about the 2000s, have been confirming like the variability of our sun in its early days.
It's a very reasonable thing. I could not find, if you can let me know about any studies that have said that about the variability of our sun, because I couldn't find anything that anybody said that it was so. But it surely makes sense.
Yeah. So there's actually quite a few papers. The first paper I think that I found popped up somewhere around 2003 or 2004. And it kind of discusses, a lot of different variabilities. So a lot of the studies are very specific, whether it be just like really active, shooting off solar flares, or some of the studies are more like the expansion and contraction of our sun. But yeah, there's a few papers. I think I've found about 8 or 9 of them. But I'll definitely send you some of those. They're pretty interesting. A lot of it's, over my head.
Well, that's just it. I need to say something else about myself. I am not a mathematician.
Yeah.
At all.
Yeah, me neither.
But
I do not like math.
I can certainly see what a study says, and then use philosophy and reason and logic to put stuff together to come up with something. And all depend on the mathematicians to do the work to make it reasonable.
Yeah, no, I agree. I definitely am not a mathematician. All right, so moving on, all that's basically with the variability, it says thus the stage of the local space was set for the unique origin of Monmatia. And it's really interesting because it's almost like the way that it did happen wouldn't have happened if our sun wasn't so active and wasn't going through that process early on. So if our sun was as stable as it is today, and Angona got passed by just the same way, it might not have even really affected us very much.
Well, there are no blind and unseen occurrences in the universe, as the Urantia book says. I think they knew exactly what was going on and when it was going to happen, and it worked out for us.
Yeah, it definitely did, because you can imagine, like, our sun gathered up all that material and probably eventually would have made planets like most systems do. It would have taken a long time, and who knows, we wouldn't have Jupiter there to protect us, and so it would have been a completely different system than what we got. With the way our system is, I mean, it's almost perfect for us. I mean, besides it's a little bit dangerous with all the asteroids and debris flying around, but I imagine all systems are going to be like that.
To some degree, yeah. No, I guess I think we got our fill.
Yeah.
Which, I mean, there is one theory that, Angela says a non-breather planet is in close proximity to us. A lot of people think it's in our solar system, but I don't see how with all the asteroid bombardments that have occurred. I would think that it would be maybe in, an Alpha Centauri or something, which is close. I mean, who knows? Maybe someday we'll find out that Enceladus on something around Jupiter is the non-breather planet. Who knows?
Yeah, well, a lot of I think the big one is Ganymede. The big moon around Jupiter is been highlighted by a lot of different readers. I've had this discussion debate with a lot of readers too, and I'm open-minded to the idea that it's Alpha Centauri or outside of our solar system. I find that a lot of readers, they take that more than interested and kind of take it to the extreme, because they basically say, well, if it's outside of our solar system, I'm not interested. So, that it has to be in our solar system. And I'm like, well, doesn't have to be, I mean, it's one of those things. Obviously, we don't know yet. We don't know. Hopefully we'll find out, in our lifetimes, but we don't know. So, but it is fun to speculate on, and it causes a lot of interesting conversations, especially with some of the people I talk to. I'm sure it's the same for you.
Oh, of course. It's fun.
Yeah.
It's so fun.
Yeah. It's definitely fun.
And we're all friends, It's not like,
yeah.
How dare you think?
Yeah. Yeah. So Angona begins its approach. And what I think is interesting about this is I've noticed a lot of Urantia book readers kind of credit, and I noticed I wanted to ask you a question. In your presentation that you gave the other day, you were pronouncing it James Johns, and I've always pronounced it James Jeans because it's spelled like jeans, G or Jeans. And I'm wondering, have I been pronouncing it wrong all this time, or?
Well, you're probably doing it right.
Oh, well, I don't know. I tried to look up pronunciation for it, and I guess you can say it either way. It could be Jeans or Johns, because if it's kind of maybe a French heredity there, I mean, I could see that it being spelled that way and it being pronounced Johns. So I wasn't sure. Well, I guess we'll have to see if somebody else in the comment section might know the answer to that question.
We'll ask him. We'll ask him when we get the Mason Worlds.
Yeah. All right. Well, I'm going to keep pronouncing it jeans just because that's what I'm comfortable with. That's what I've always done. So it's really interesting that Matthew Block, in his source work, he credits genes for the next section, which is paper 57, section 6, but he doesn't have a source for section 5. I discussed with him a while back, and he sent me a rough draft of something he was working on. It's not on his website, but he doesn't really have a source for this section that we're talking about today, section 5. Through my own personal research, I've kind of come to the conclusion that there might not be a source for this section, because it's kind of a combination of what James Jeans had done, but what was also done before him with the Chamberlain-Moulton hypothesis. And the mixture of those two things and the Urantia book, they kind of melds together like a unique story in itself. So it's almost like this part is actually a little bit revealed to us, because as far as I can tell, as far as I've found or anybody else has found that I know of, there's not really a for sure source on this section. So that's always really interesting. But one thing that's different between the what James Jeans hypothesized and Chamberlain-Moulton is Genes has a star passing kind of close, and it pulls out one filament,
One cigar shaped.
the cigar shaped filament that eventually makes up the planets. The Chamberlain molten is more of, it kind of happens in stages. As it gets closer, a little bit gets pulled out, a little bit more. As it gets a little bit closer, a little bit more, and eventually, a big portion gets ejected. And the Urantia book kind of explains the same thing. It kind of happens like as a process over time. And I believe they specifically say it was about 500,000 years was the process. And then there's basically one massive event, which they call a partial disruption. And it's really interesting because partial disruption has become really big in astrophysics now. They've detected black holes or high mass objects, dark objects that have gone close to a sun and caused these partial disruptions. And I actually even have a diagram of it, or a video illustration of it, that I will post on here so the viewer can watch. And it's really interesting to see because it kind of gives you that visual of what probably happened to our sun. Now this illustration that I have is kind of an extreme example. I don't think that partial disruption of our sun was that extreme, but I don't know. I mean, it's if it was that extreme, you can imagine this big filament was, a lot bigger than I've always imagined it. But if you think about, like, I think what's the mass of our solar system as we know it, like the planets, isn't it like less than 1% of our sun, the rest of the solar system?
It's just single digits for sure.
Yeah. So you imagine, like, that material being pulled out of the sun. It's not a lot. It's not, I mean, I know the sun eventually pulled a lot of material back in, but I also wonder, as material's getting pulled off and it's getting a little bit further away from our sun, when that big disruption happens, like all that material that was kind of getting away would have been like, expanded even way further away. You would think it would be almost like a shock wave, right? That's kind of how I imagine it. And I've always wondered if that was like how we got like the Kuiper belt and the Oort cloud, because those are kind of anomalies of why we have those.
Well, those are, one thing is where there are a lot of known unknowns. And the Oort cloud to me is really fascinating, because I really think that the Oort cloud is not just an elliptical thing around the sun. It's spherical. It's all around Monmatia, which tells me that the Oort cloud was probably the debris from the dust from when the terminal disruption of Andronover occurred, and that it's just leftover junk that is way out there. I mean, it's way out there, and so far, and it's just throwing comets at us every so often. Even Planet 9 goes out to 1200 AU in its theoretical thing, which is just on the edge of the Oort cloud. But it's way out there.
Very, very interesting. And the Kuiper belt is, very fascinating itself. And those are actual objects that we've been able to study. We haven't really been able to study much, from the Oort cloud, but at least the Kuiper belt we have.
Well, it's brand new. The very first Kuiper belt object that was found was theorized, but the first one that was found was 1992. I mean, my gosh. And since then, they've found thousands of them. So it's something else.
Yeah. So the Urantia book talks about, so after Angona passes by, we have like this partial disruption, and then Angona kind of goes on its own merry way. And the 5 inner planets and the 5 outer planets start forming in miniature. and then you've got the two central planets from the central bulge, Jupiter and Saturn, which they named specifically. And then the 5 inner planets, I think we pretty much know. I mean, Mercury, Venus, Earth, Mars, and then it explains in section 6, the asteroid belt was the 5th planet of long ago, and it was disrupted by Jupiter and became the asteroid belt. But what I always find fascinating is nobody seems to agree on what the other 5 planets, the 5 outer planets, might be, and that's always a fun topic for discussion. So I'm hoping we can talk a lot about that. We've talked about Uranus, Neptune. I think I did ask you one question about that in your presentation. If you thought it was possible that before we get too far ahead, we also have the possibility that we might have captured 3 planets from Angona. Now it talks about 3 Angona planets, major planets, were detached, but it doesn't specifically say if we captured them or not. So, I mean, they could have been detached, could have been slingshotted somewhere else off into space, could be, anywhere, or they could have been captured by our sun's gravity, and they could be in our system. So we could have potentially 12 planets, or we could have potentially 15 planets. So that's always interesting to think about. So I want to ask you about, because we talked about Pluto in your presentation. I always thought, and this is just kind of the way I looked at it, is Pluto was discovered in 1930. That was right before the 1934-1935 era of the Urantia book. So I always kind of considered that, the Urantia book would have considered Pluto a planet. But I also find it really interesting that the Urantia book mentions every planet by name except for Uranus, Neptune, and Pluto. So, what are your thoughts about Pluto?
Well, I used to think that Pluto was a planet from the Angona excursion, but that it was somehow knocked out of orbit. But it has 5 moons. I mean, that's, so I just thought it was disrupted by something and was sent into this crazy erratic orbit. But I don't think so anymore. I kind of agree with the Astronomical Union that it is purely a Kuiper Belt object, just like Eris, Makemake, and all the other wonderful little dwarf planets, because it does not have a circular orbit, and it is not aligned with the ecliptic, which is 6 or 7 degrees above the equator of the sun. So I'm just going with the idea that it is indeed a Kuiper Belt object, and that's where I'm sitting today.
Yeah. So that means that we have a lot more planets to find then. If it's just Uranus and Neptune, Pluto's not considered a planet, and those other smaller Kuiper belts. So that means we have 3 more planets to find?
Right. Yes, indeed. And that's what we haven't found them in my hypothesis. We have not found them because, just like Planet 5, they were the 2 of them at least, maybe one. I don't know. It's a known unknown. But I'm hypothesizing that they were 2 of them were disrupted, tidally disrupted. And the formation of the Kuiper Belt, the cold classical Kuiper Belt, is the result of those disrupted planets. They don't exist anymore. They're gone. They are the cold classicals. Now there's the hot classicals and there's the cold classicals. The cold classicals are just they're near the ecliptic and they're in a circular orbit. So that's one of the reasons I think that it is a result of tidal disruption. But they are not big right now. They're about 100 kilometers, most of them, and they are far spread apart. You can imagine that's a far distant, 42 to 47 AU. So that's a long way away. And they're just sitting there. And current science says, well, they've always been there. But I'm saying, no, they didn't. They were a result of the tidal disruption of planets 10 and 11. Now, planet 12, I'm thinking is going to be planet Y, which is something they haven't found, but they're seeing some mathematical reasons that it might exist. And Vera Rubin telescope is going to say whether or not it does exist. Now, the hot classicals are all those dwarf planets that are in these wild, long elliptical orbits that come close to Neptune. And they're dwarf planets, and they seem to be affected by the gravity influence of something. And, Konstantin Batygin and also, what's his name?
Mike Brown?
Mike Brown have hypothesized that there is a planet 9 that is going around and spilling them into these elliptical orbits. So, and the cause of them, you can speculate all day long about what caused them, but I'm thinking that one of the major planets from Angona collided with Uranus and spread those dwarf planets eventually into the Kuiper Belt. But then again, that's just my hypothesis. I'm trying to put it all together,
Yeah. Well, it's definitely an interesting hypothesis, and I was pretty surprised by it when I heard it. And read a little bit about it. Because I had not heard that particular hypothesis before about planets being disrupted. Planets 10 and 11 being disrupted. So it's definitely something really interesting to consider. And if you don't mind, I kind of like to run my hypothesis by you.
Oh, I love it.
Really quick. And mine's kind of an older formed one. I haven't really updated it or done much research on it recently, but I did kind of form this hypothesis a few years ago. And so my hypothesis is that Uranus and Neptune are actually captured planets from Angona. And one of the reasons that I considered that is because, for one, astronomers don't believe Uranus or Neptune could have formed where they currently are. They believe they would have had to been further inside, on the inside of Jupiter, and eventually migrated out. Now, that's possible. I mean, that could have happened. I just, with what the Urantia book says, it doesn't really fit, because it says they formed in miniature, the inner 5 and the outer 5. It doesn't say anything about extra, planets forming inside and then migrating out. So, specifically says the inner 5, outer 5. So I always considered that they would have had to have formed outside of that. Another reason is through Konstantin Batygin and Mike Brown's work on Planet 9, they estimate that it's probably a Neptune-sized planet. And through my research of exoplanets and multiplanetary systems, when I was doing the Monmatia less than 1% video, I discovered that most multiplanetary systems, all the planets in those systems are pretty much equal in size. We're kind of the oddball because we've got, the small inner, and then we've got 2 big planets, and then some ice giants with Neptune and Uranus. And then we got little planets outside. Like, most systems that we found aren't like that at all. They're like very balanced in terms of the size of these planets. And so I've always pictured if we captured three planets from Angona, they're going to be relatively similar in size because that's what we see in other systems. And so Uranus, Neptune being relatively the same size, planet 9 being relatively supposedly the same size if we discover it. I'm with you on through all their research that I've looked at. I think they're definitely onto something. I think they're going to find it. I've been waiting though. I remember in 2016 I think that was around when I first found their research, and they said we're going to find it within 10 years, and they got about a year left. So, and now they're saying, well, we're going to find it within about the next 5 or 10 years. It's like, well, you already said that 10 years ago or 9 years ago.
They had to wait for the Very Rubin telescope.
Yeah,
there's that's required at this point.
Yeah. Well, Constantine did it was on a documentary that I watched. And it was a really interesting way to look at it. He was on a baseball field, and he was like, had a camera set up at home plate. And then he walks way down the line past first base, halfway into the outfield, and he puts up this like black screen, and then he takes like a little piece of white tape and he puts it on there. And then, from way back there at home plate, like he's like, that's what you're looking for. But that's if the sun were actually hitting it. He's like, this planet's so far away from the sun that it's actually dark. So then he cuts off a little piece of black tape and puts it on there. And you're like looking at this like up close, and you still can't even see the little piece of black tape, up close. So, and he's like, it's like trying to see this from, back there at home plate. And yeah, it was a really, it kind of put the idea home that it's what they're trying to do is nearly impossible.
All they have are the mathematics.
Right.
It's a mathematical thing. Something's causing those etnos. Something is doing it. It didn't just happen that way. You've got to figure out what it is. And now some people are saying planet Y does it, because they're thinking it's a little less than 200 AU out there, and it might be causing it. So if they can find planet Y and then do the mathematical calculations, maybe that's it. Maybe planet 9 does not exist. It might not. Maybe it's planet Y. I mean, these are all things. That's why it's so fun to anticipate what's going to happen in the next 10 years. Because this is the golden age of telescopic astronomy. I mean, things are happening in astronomy that are just absolutely mind-boggling, exponentially. It's going up. And we're going to find things in the next 10 years that blow our minds.
Oh, yeah.
Imagine right now what we're going to see. It's so exciting.
I know, it's so exciting. It's a fun time to be alive, especially if you're really interested in astronomy and it's just amazing, like some of the discoveries that they're being able to make because of our technology, and our improvements on our methods. And yeah, it's a lot of fun. And so, I just on your point there is, it's possible that both planet 9 and planet Y could exist, right? Like, I don't know too much about planet Y, but I've really been following the planet 9, and I mean, it's possible that they both could exist, right?
Oh, yeah. Well, I mean, I would think that planet Y would be the 12th. That's my hypothesis, is that it is the 12th planet from the Angona excursion. And it's way out there. And that all those dwarf planets came rushing by it and got thrown out. I mean, that's a possibility. That's one of the hypotheses that they can explain the extreme anomalous elliptical orbits of these little dwarf planets. So it could be planet Y, it could be planet 9, it could be both. Yeah, we'll find out, I hope.
Yeah, I hope so too. Yeah. So I am friends with Constantine Madigan on Facebook, and I have had a conversation with him once in a private message. And I did kind of try to explain to him, like, a theory. I didn't use like the word Angona or anything, but a theory about his son passing, and he wasn't dismissive, which was nice. I appreciate that. He was, he's like, it's definitely something that's possible. So I like that he was open-minded to the idea and stuff. And I actually think he wrote a paper not too long after that kind of elicited a possibility of that. And if I could find that paper, I'll put it on here. But
he is
what's
so
that?
nice. He is so nice.
Yeah, he's a very nice guy.
I emailed him too. I emailed him and he responded to me twice on some questions I had. And he's also a rock star. Astronomer, rock star astronomer, and he plays the guitar.
Yeah.
He's a rock star and the guitar. So
yeah,
he is wonderful. And a mathematician, polymath, amazing guy.
Yeah. Yeah, I really like him, and I enjoy following him on Facebook and a lot of the stuff he posts. And again, a lot of it's over my head, but a lot of it is very interesting. And he usually in his posts, when he has like a paper published or something, he'll kind of break it down with like some pictures and some diagrams, and it'll be almost like small enough to where it's it'll be like an original post and then comment, where he'll do like 5 or 6 comments where he'll just kind of like break it down in a way that is understandable. And I really appreciate that. Because reading some of those scientific papers can be really daunting, and yeah. And it's like, you can read a whole, sometimes you read it 3 or 4 times and you're like, I still don't understand what's being said right here, so it's nice to, have a scientist that's especially as smart as he is, and he's super genius. I don't really understand his papers, but when he breaks them down, it makes it a little bit more understandable. So yeah. So Constantine, if you're watching this, we love you. You're awesome. Anyways, so moving on. Back to my theory though. So I, with Uranus, Neptune, and Planet 9, if I'm considering those as captures from Angona, then I think of, okay, so there's 5 other planets, outer planets that are native to our solar system, or not from Angona. And so I've always considered Pluto, Eris, and Triton. Triton being a moon of Neptune that is pretty much, so if you look at Pluto, Eris, and Triton, I mean, they're almost identical. They're relatively the same size, relatively the same mass. And so it always comes back to me for that debate that happened in 1931, whether Pluto should be considered a planet or not. And then they said, yes, Pluto should be considered a planet. And so I've always imagined the revelators would have had that information or known that information. We consider it a planet, so they would have included that in the definition of a planet. Could be wrong. I don't know. But, and so I'm thinking we're looking for Planet 9, which is going to be one of the other Angona planets. And then we're also missing 2 Pluto-like or bigger planets that are going to be ice planets like Pluto. And the other Kuiper Belt objects, Maki and Sedna, all those ones are quite a bit smaller than Pluto. So I consider those, if we were borderline questioning whether Pluto should be a planet at that point, like, I think anything else smaller than that, they wouldn't have considered. And there is a definition, I remember, I'll look it up as we're talking, but I think it was on paper 15. They actually define planet. And it's kind of vague. It doesn't give us the answers we're looking for, but it does kind of give you a framework of, at least a definition of how they're defining a planet. So, anyways, that's my hypothesis, my theory. It needs some refinement, but yeah, hopefully we'll find out someday soon.
Well, the problem I have with it is that Uranus and Neptune both are on the on the ecliptic. I guess it's possible with your theory that they could have gravitated to that ecliptic, and they also have a circular rotation around the sun. They're not elliptical, and as a result, that's why I think they are the 8, 9, 7, 8.
Yeah.
7, 8.
8, 9.
Okay, 8, 9, right?
Yeah,
Okay.
because Jupiter and Saturn would be 6 and 7.
Josh, I'm no good at math. So that's why I think that they are. That they are part of the Angona extrusion. It's just that we haven't found 10, 11, and 12. And that's odd that we haven't found them, because telescopic availability should have gotten them by now, if they are anything of any size. And we're getting these tiny, tiny little dwarf planets. Why can't we get the other ones that should be out there, but they've not been found? So that's why I'm thinking they were tidally disrupted. That's my convenient way of saying they used to be there, but they're not anymore.
Yeah.
Because there's one thing that Rangebook says, those kind of tidal disruptions are very common in the cosmos. Now the big ones are very uncommon, but the small ones are very common. So that's where I'm going with that.
But you'd still need a big, I mean, depending on obviously the sizes, like what was disrupted, how big was the planet that was disrupted?
Yeah.
If it was a smaller planet like the size of Pluto or something, you can see it. But if it's a bigger planet like the size of Neptune or something like that, it would have to be something really massive to disrupt it. So that's where I'm like, well, what could have actually disrupted a big planet like that? And the only thing I can really make sense of something being disrupted out there, it would have to be a smaller planet. But then, if they're smaller planets, then it's like, well, then Pluto and Eris and these other smaller planets also fit into the realm of planets, I guess.
Well, I am guessing that these disruptions that occurred had to have occurred very early in the 4 billion years ago or something, and and so they formed the cold classical Kuiper belt at that time, and that the only thing I can think, that's a known unknown. Exactly what was the disruptions? What disrupted them? I mean, I can't go there because it's an unknown thing. Now, so I'm just saying, well, somehow or another they disrupted. I don't know.
Yeah. I did find this definition of planets here too, real quick. So I'm just going to read this real quick.
Oh, great.
This is paper 15, section 6, paragraph 14. The planets. These are the larger aggregations of matter which follow an orbit around the sun or some other space body. They range in size from planetesimals to enormous gaseous, liquid, or solid spheres. So, I mean, that kind of gives you, they range in size from planetesimals.
It does say that the Angona extrusion is an example of one that is less than 1% of the way. Now, I think the rest of them are probably from the planetesimal accretions. The nebular hypothesis, which came around in the 18th century, Laplace, Pierre Laplace is the one that came up with the best of all those planetesimal accretion theories. And that's probably the way most of them do. They're just slow accretions that eventually build a whole solar system. But that, not us. We're really weird.
Yeah. Well, that's like if you go to the origin of space bodies, it's paper 15, section 5, and it gives you 10 modes of how systems and bodies form. And the concentric contraction rings, to me, like reading that is exactly like the hypothesis you're talking about, and how our current science thinks that most all solar systems form. They think that's how our solar system formed. But we see that is what is happening. We've gotten the ALMA array has gotten actual visuals of planets forming in the accretion disk around a sun. We see that is a way that they do form. But and like I said, our solar system probably would have formed that way had not been from Angona. Would have formed completely different, would have been radically different. But since we had the Angona excursion or intrusion, we got what we got. It's a really unique, and like you said, less than 1%. And it's interesting that in science they have also determined that less than 1% of solar systems that they've studied that have more than one planet are anything close to ours, are configured in any way close to ours. Less than 1%. They actually, it was interesting because the Urantia book uses that specific term, and I think it was like an article from like 2014 or something, and they use the exact same term. They're like, less than 1% of solar systems are like ours, and I was just like, well, there you go. The Urantia book goes on and gives all kinds of different interesting ways that solar systems form, and then at the end of this, they say it would require the narration of almost 100 different modes of sun formation and planetary origin. There's so many different ways that solar systems form that we're not going to tell you all of them. There's over 100, but here's a couple. Here's a few to kind of
So get started, try to figure it out.
Yeah, exactly.
Well, that's the wonderful thing about the Urantia book, is that it just gives just enough information to not only increase your knowledge about what could be or what happened, but it gives the opportunity to expand and jump on the shoulders of the Urantia book and say, okay, well, let's see. This is the way it could be. The Urantia book is wonderful that way. It just gives enough information to spike your interest.
Yeah.
But it doesn't, give me more. I want more.
I know. But I mean, that's the fun part too, is you got to try to figure it out, right?
Yeah,
so
well,
if they just gave you everything, it would kind of be like, well, okay, the fun part is like trying to figure it out, trying to learn. And yeah.
It's the only way we can grow. If it was given to us completely, we get lazy. We have to figure it out. We got to do the work. And the Urantia book on cosmology gives us a little better foundation. It wants to correct things that that we need to realize going down the road, that these models are going to need to follow what the Urantia book is saying as a foundation of what the solar system and the universe is made of. And boy, is it a tough task.
Oh, so another thing that you had brought up that the Urantia book talks about is the axial tilt, the 7-degree axial tilt of our sun and our equatorial plane, and that being explained in the Urantia book as from the Angona incursion. And what's really interesting to me about that is, with our current theories of how our solar system had formed in science, that's one thing that they haven't been able to explain, is that tilt. And
we've tried. I mean, the biggest one is there was a the sun was very unstable in its protoformation, and the geomagnetic influences tilted it a little bit, and that's where it went. So, I mean, there's a lot of things that are explained in many theories that geomagnetism caused it. If you don't know what caused it, blame it on geomagnetism. like the angular momentum of Jupiter. And the reason that it doesn't, turn into a lenticular form with its angular momentum is because of geomagnetic forces that are preventing it from going any faster. Because, boy, it's spinning fast. 10-hour day. That's fast.
Yeah, well, especially for something that large,
Oh,
right?
yeah.
I mean, in your presentation, you wanted to go more into the formation of the asteroid belt. What's interesting to me, current science thinks that the asteroid belt's just always been there. It never formed into a planet. You know, it's just leftover dust and material from the beginning, and you know, that whole thing. But what's interesting about that is they used to think the same thing about the rings of Saturn. And then we get the Cassini mission and basically discovers that the rings of Saturn are very young. They're only 100 million years old. Well, obviously, 100 million years old versus 4.5 billion years old, they haven't always been there. And then that new theory came out with the moon. Crystallis, I think, is the name that they give this moon. That was disrupted and it formed the rings of Saturn. You know, the science is pretty solid. I mean, it's pretty much almost, you know, you can almost say it's been proven. It's a done deal. The rings of Saturn are a disrupted moon that broke up, and the rings are slowly disappearing. Unfortunately, they'll be gone in about 300 million years.
Yeah, I read that recently, that they'll be gone.
Yeah.
Which is a segue to another theory I have. The asteroid belt, as we know from my revelation and from James Jeans, is that the asteroid belt was formed because of the tidal disruption when it came too close to Jupiter, right?
Yep.
I think that a lot of the debris from that disruption caused a massive amount of rings around Jupiter that have since dissipated. And there's one little ring around Jupiter now. But I think, and so that's a lot of what happened to poor little Planet 5, is that it became a lot of the rings of Jupiter at that time. And also became Trojans and Lagrange points around Jupiter, and also dispersed north of Jupiter, and mainly south, of course, which is the asteroid belt. But they're everywhere. They're all over. And of course, one of the main things that they're saying that did not, that proves, and you talked about that. Well, what is it? The Psyche mission. The Psyche mission is trying to find out what in the world Psyche, an asteroid, is made of, because it's mainly made up of nickel and iron and some silicates. But you wouldn't find that anywhere except in the core of a planet. So the Psyche mission is going to be, it's going to rendezvous with Psyche in 2029. And boy, that's going to tell us something about that little thing. And so it just seems so clear to me that there was a tidal disruption that caused the asteroid belt. And that's just one of the pieces of evidence. But they found on the moon, they have found different asteroid evidences of variable iron contents that they say prove cannot come from the asteroid. They come if they would be the same if they were from the asteroid belt, but they're not. So I mean, we've got to figure out why there are different iron samples that have different qualities that need to be explained as to why that's true. You know, I have my theories about that too, of course. You got to put it all together somehow.
Yeah. Yeah. And that's, you know, it's really interesting because, you know, I'm really, really interested in the, excuse me, I'm really interested in the Psyche mission. And, you know, it seems like it has to be the core of a planet. And another asteroid that's really, really interesting is Eros. And they say that Eros has more gold content on the asteroid than the entire Earth itself, which is really, really, I mean, that basically to me is like a smoking gun. I mean, that you can't have that unless it came from a planet, like the core of a planet. And, I think that in a sense, if you tried to do some research on the gold content of Eros, um, it's a little bit suppressed. I think because of the consequences of it.
The standard model, the standard model that everybody is supposed to adhere to.
Well, not just that, but the potential for the future of Earth's resources and gold mining, and like
Oh,
Eros like could be the next big gold rush.
bring
Right.
bring it in.
Yeah. And so it's like, well, okay, wait, let's not talk about Eros. Let's not tell everybody that has so much gold on it, because, now these rich companies are doing, a lot of space things, private companies. I mean, it's going to be a race to who can get to Eros and mine the gold off of Eros. And then, you know, they bring all that gold back to Earth, and then the price of gold, plummets, and it throws our whole economy. There's repercussions. So it's definitely interesting and worth looking into. And I've done some research on some other meteorites, meteorites that have fallen to they found in Antarctica and other places on Earth. There is a lot of evidence that portrays that they could have been from a larger body, not just dust. Like these crystalline formations that are built up in them, like they definitely came from a larger body. It doesn't prove that it was a planet-sized body, but it was definitely something a lot bigger than what these little small fragments are. And I think they've estimated some of them like something as big as like 30 kilometers. Obviously, that's not as big as a planet, but then when you start putting in Psyche and Eros and some of these other things that are pretty massive that have this metal content that was like that could have only formed in like the core of a moon or a planet size object, so it's going to be really interesting to see what we find. And I think that might break the bank on some of the old theories. I think Psyche's going to really flip the script there.
Well, they're so rare. Those iron meteorites, there's not many of them that are found. When they do, it's like, where'd that come from?
Yeah. Well, and another part of the theory of why a planet didn't form there is they say, well, there's not enough mass. There's only 4% of the moon's mass exists in the asteroid belt. Where's the missing mass? But, look at what's happening with Saturn and its rings. It's going to lose its rings, all that mass, through a process called ring rain. Now, if the sun had a giant ring of dust around it, you can imagine the sun would have pulled a lot of that dust and the stuff back in. A lot of it probably was a process similar to what's happening on Saturn with the ring rain happening with the sun pulling in a lot of that matter. A lot of the stuff probably flew all over the solar system. You look at Jupiter and Saturn alone have 220 irregular moons, and 83% of them, I think, what I was researching, are in retrograde. So they spin backwards. So irregular moons are like basically captured asteroids, and they're not really moons. Where did all those captured asteroids come from? I mean, a disrupted planet in the asteroid belt. All those asteroids went everywhere. And if they went all the way, to Saturn and Jupiter, you imagine they went beyond, because, I mean, you look at some of the irregular moons of the outer planets.
I agree.
And I mean, it might be material in the Kuiper Belt from it, and a bunch of it probably fell back into the sun. So it's not really hard for me to imagine where all that missing mass went. I don't know why that seems to be a problem with astronomers, and I just don't think that you would expect like it would all still just be floating right there. No, it's all went all over the place.
It just seems so obvious.
Yeah.
It's only 4% of the moon. It can't be. I thought, well, in billions and billions and billions of years, yeah, it's scattered. And, we got some of it, and of course, Jupiter got most of it. over the time, and it just seems obvious. Occam's razor. It just seems like the most easiest thing to say that happened this way.
I agree.
They also say that the reason all the asteroid belt never formed a planet. It never formed a planet because of Jupiter was constantly jostling it and preventing it from happening. That's another one of the theories. So, a lot of theories to overcome in the next 1,000 years.
Yeah. Well, I think between the Lucy and the Psyche missions, I think those two missions will give us a much better grasp on what's really going on in the asteroid belt.
What's the Lucy mission? I don't know that.
The Lucy mission is the one that's going to the Trojan asteroids.
Oh.
Yeah. That actually launched before Psyche. They're both really good missions. They'll teach us a lot. So, yes. I mean, I think we've covered a lot of ground here. I don't know how much.
Well, the only other thing is the theory about why Venus is tilted retrograde, upside down, and spinning the wrong way.
Yeah.
You kind of gave me another theory about that it was actually a passing, one of the major planets from Angona passed by really close, very rapidly, and they might have been about the same size, Venus and this major planet. And by it turned it up, or maybe not the same size, maybe the major planet was smaller than Venus. It came by Venus, tidally disrupted, but in the process, turned Venus upside down. But as it tidally disrupted, it made a bunch of junk that just flooded the inner planets. So, and that's where those enormous space bodies came from that helped Urantia 2 billion years ago grow from 1/10 of its size to its present size. I mean, they would take a bunch of enormous bodies in a major bombardment to cause that. So where did those enormous bodies come from? That's the best theory I can come up with, unless you want to say they came from the asteroid belt, which is another possible theory.
Well, yeah, you have the late heavy bombardment, where we see these massive cratering all over the moon, all over Mercury, right around the same time. So something right around that time was going on, and you can kind of picture disruption of the fifth planet was a big part of that, but something else, the Angona, like there's a lot of moving parts, right? A lot of different things that could have been happening really close to the same time. And yeah, I mean, if Venus was hit or, something passed by it and caused Venus to flip and it disrupted, that could have been part of it too. And I imagine that, we don't know what the size of this planet was that was disrupted, the fifth planet. We don't know if it had moons. Maybe it had 5 moons. Maybe it, we don't know. So, I always kind of think of Ceres. I mean, it's perfect sphere. Where did that come from? How did that? If a planet never formed in the asteroid belt, where did Ceres come from? And
I've speculated about that. I don't know the answer. I thought maybe it was a moon, but it seems like it would have disrupted too. Maybe it's just the accretion that occurred. One more thing: the late heavy bombardment. I don't know why they call it the late one, because it was early. The thing happened about 3.5 billion years ago, and I think that was the Kuiper Belt bombardment. And then the Venus collision would have been the 2 billion years ago. So we've got 2 different bombardments. The bombardment that happened, the late bombardment, which was the Kuiper Belt bombardment, and then we had the 2 billion years ago, which would have been the the Venus bombardment. But, I'm just trying to put the puzzle pieces together.
And there's so many pieces to this puzzle, and it's great that the Urantia book kind of gives us a picture, right? Because putting a puzzle together without the picture is really difficult, and I think that's what scientists are trying to do. They don't really have the picture,
Right?
But the Urantia book kind of gives us, it's a little blurry, but it kind of gives us a picture.
Yeah, but the science does give us the mathematical possibilities of so many things that can be applied to astrophysical research in the future. When astrophysicists finally do decide, well, hey, maybe this Urantia book and James Jones had something, and right, it'll happen.
It's inevitable if we do. We keep doing science, we're gonna slowly figure these things out, and they're. I mean, if you look over time, it's very clear that things, just more and more new discoveries keep aligning more and more with the Urantia book, and that's a process, I guess, that you can kind of just see continuing to happen, and it's going to continue to happen until eventually we get it figured out, and eventually you never know, it might be some genius astrophysic comes along and he reads the Urantia book, and then he starts, okay, I gotta look into see if, and he starts looking into specific things that are in the Urantia book and finding out, hey, this is true, and then then discoveries can really ramp up.
Well, and then again, we might, once we've exhausted our evolutionary effort to find out what's going on, we'll get more revelation. But we have to exhaust our evolutionary efforts to get there.
Yeah.
So
Yeah.
Someday.
Yes. Yeah. And back to Ceres too. I mean, I've always thought it's got to be a moon, right? Like, what else could it be? Had to be a moon from maybe not the planet that was disrupted, but maybe Jupiter. I don't know. Like, it's
either the moon or it is the result of accretion since the disruption.
Yeah.
And then, but it's one or the other.
Yeah, it could be. It's interesting too, the really bright spot on Ceres. Have you seen that?
No.
Yeah, there's a really massive bright spot, and it might be just from a impact or something, but it almost makes it seem like Ceres has got a lot of ice. Ice equals water. Interesting thought. I mean, of course, the conspiracy world is like it's actually a light, and it's a city on the backside of Ceres, and aliens, and who knows? Maybe that's where the non-breathers are.
Well, have fun with that. I'm just a scientist in terms of what I see.
Yeah.
The thing is about Ceres is that it is in a circular orbit with the asteroid belt. It is on the ecliptic, and it is consistent with Titus Bode's law. And Titus Bode's law is a formulaic prediction, and all the planets in our solar system adhere to Bode's law, which is not a law, it's a rule, up to Uranus, but Neptune does not. But Ceres does. Ceres is right there.
It's interesting too that you bring that up, because they started doing some research with Titus Bode law on other solar systems, and it seems to work. So yeah, so that was kind of interesting, because once they found out Neptune didn't kind of fit the bill, they kind of wrote it off a little bit. It's like, well, must be just an amazing coincidence, or there's something to it, but we don't really know. Or now that they're studying other solar systems and they're kind of finding that same spacing kind of lines up in some of these other solar systems, and they're like, oh, okay, maybe there is something to this.
Well, I'm totally perplexed about why Neptune doesn't fit in. It's about 9 AU short. And, maybe it just hadn't finished gravitating there yet. I don't know.
Well, it's also, isn't it slightly elliptical, Neptune's orbit? Or is that, I know that the orbits of Pluto and Neptune, like sometimes Pluto's actually closer to the sun than Neptune. But I don't remember if it's because Neptune's orbit is funky or if it's because Pluto's orbit is funky. It's probably Pluto, but
I think it's Pluto because Pluto comes inside of Neptune's orbit. And it's in resonance. It's a 2-to-1 resonance. Every 2 orbits of Pluto, there's 1 orbit of Neptune every time. That's why it's never hit Neptune, because they're in total resonance with each other. So they'll always be there.
yeah, I think we covered a lot of stuff. I mean, we didn't really talk about the Mercury thing, Mercury and the moon. I mean, that's
an ongoing argument that always occurs.
I mean, to me, it's a process. It's showing a process and I guess this would be a good one to talk about is the processes of tidal breaking, the processes of tidal friction, tidal heating, and tidal disruption. You know, these are all part of the same thing, these tidal forces. And it's really interesting because the Urantia book speaks heavily about tidal forces, which tidal forces weren't really talked about that much in the early 1930s. It wasn't really until we started discovering what these tidal forces were doing around, Europa, around Jupiter, moons of Saturn. These tidal forces have gotten a lot of attention in the last 15, 20 years. And, it's because we're actually witnessing them. I mean, the first time we witnessed it was when comet Shoemaker-Levy 9 got too close to Jupiter, got disrupted, broke apart, and then all the pieces just slammed into Jupiter. Up until then, these were just like theories of, oh, that could possibly happen. But then we seen it happen, and it's like, okay, yeah, that definitely can happen. And so, these tidal forces are, gotten a lot of publicity, I guess, since then. And it's really interesting that, these are talked about so much in the Urantia book, like the process of tidal friction, where the slowing down of a rotation, tidal breaking as it's describing this process, and then that tidal locking where the two bodies keep the same face towards each other. The Urantia book explains all this, and it's really interesting that, it's like how you read that sentence. But if you understand what it's saying, it's talking about a process of tidal breaking, eventually leading to where it'll be tidally locked, keeping the same face. But it's giving the example of Mercury is slowly breaking, and the moon is locked, right? And so that's always an important distinction, because that gets thrown out there, like you said, a lot.
Well, yeah, it depends on how you interpret the English language about how to describe it, because they say illustrates. It illustrates it. It's illustrating the fact that it's tidally breaking and showing down. It's illustrating it. It's not there yet, but it will be.
And it's interesting how they structure that sentence, because it says, as is illustrated by the planet Mercury and by the moons, which always turns us, it's separating that. It's clearly separating those two thoughts.
Exactly.
It's not, it's explaining this whole thing of breaking as illustrated by Mercury, and then also by the moon, which turns the same face. So like you got one example of breaking, one example of locking, and it's explaining both of those. And and so I can see how people can read that and be confused, but it's just a simple
Oh, it is. I think it's clear.
Yeah, it's very clear. Yeah. So always fun to throw that in there, though, just in case somebody's not clear on that. Yeah, this was something I learned recently too, and I didn't know this, but did you know that Venus's retrograde wasn't discovered until 1962?
I did not know that. As a matter of fact, I was getting ready to look that up when I noticed that you wrote that.
Yeah,
I forgot to, but wow, I did not know it was that recent.
I didn't either. And when I found that, I was like, really? It seems like we would have figured that out a long time ago. But I think maybe because of it rotates so slowly. I don't know. Um, yeah, I mean, I think we've covered a lot of ground here. Is there anything that you want to talk about?
Well, we've talked about it. We've started at the Oort cloud, moved into the Kuiper belt, the hot classicals and the cold classicals, came down to Neptune. The only other thing is it was the Nice model, Nice, France. A whole bunch of astrophysicists got together and decided they would figure out exactly the origin of the solar system. And the theory that they had in 2003 was right. And you mentioned this earlier. The migration of Uranus and Neptune came up and disrupted the Kuiper belt. That's what caused the late heavy bombardment, and that was before the hot classicals were discovered. That was before Sedna and Eris and Makemake and all those. So they're the hot classicals are clearly came, I think, from Planet 9 or Planet Y. But at the time, that's all they had. They said, well, something caused that late heavy bombardment. Let's move Uranus and Neptune out until they hit the Kuiper belt and cause that disruption. And I guess there's mathematical constructs that can demonstrate that planets can change places even. I don't know about that, but that was the best they could do in 2003. So that's kind of outdated now because of the concepts of Planet 9 and all the ethno behavior that's occurring. So bye-bye Nice model.
We got a lot of work to do to figure it out, but yeah, I do appreciate a lot of scientists that are working on a lot of this stuff and trying to figure it out with an open mind.
Well, if I can turn this into a spiritual thing,
absolutely.
I think our solar system is exponentially more complicated than other solar systems. And I believe, and I said this in my presentation, that one of the reasons, it's a minor reason, but I think it's a reason, that Michael chose Urantia to be his final bestowal. One of the reasons is because of the way that Monmatia formed. And he knew that it was going to cause a huge amount of difficulty for Urantia astronomers to figure it out. Whereas if it's a simple planetary accretion or in a protoplanetary disk with all the planets with the same angular momentum, and that's simple. But us, because we have a dual origin. We not only have the extrusion from Angona, but we also had planetesimal accretion. We had a dual thing. And it's just so much more complicated. So, Jesus, thank you so much for giving us the challenge that you gave us in choosing this wonderful planet for us to enjoy and to be in awe about.
Yes. Amen, brother. I agree with that. That's actually a really interesting point that I had never even thought of until your presentation. And I was like, it kind of makes sense. Like not that it's a big reason, but it is an extra small reason that makes sense why we even need more help, right? We need so much help for so many different reasons because we're so backwards, and
Lucifer, Adam and Eve,
yeah,
extensive bacterial and fungal infections. All that stuff is just, I mean, and then we got Monmatia.
Yeah, we got this confusing, jumbled solar system that doesn't make sense and doesn't look like any other solar system that we see. It's like, what happened? And so
we're at the bottom of the barrel, but we're going to, the last shall be the first.
Yes.
No doubt not.
Yeah. I mean, so many worlds he could have chosen, and the fact that he chose ours, that's good. That's pretty makes us feel special, I guess, in a way. Yeah, very
special. Won the lottery,
right? It's like winning the lottery.
Many thanks to Jesus and the angels that are helping us figure this stuff out too.
Yeah. Amen. And I think, that's probably a good place to end it on that note.
Well, yeah. I mean, that's the reason we're here.
Yeah, absolutely.
It's the reason we have this curiosity.
Well, Tom, it's been a blessing to be able to sit down and talk to you about this. I really appreciate your time and you doing this with me. And hopefully this is going to be serviceable to some people who watch it. Maybe learn something, or maybe they can add something to this conversation that we didn't think of or that we don't know, some new information. Please, share thoughts in the comments, because we're definitely not experts. We're just two very interested people who are trying to figure it out and exploring these things. So if you've got some insights, and you're watching this, please share them with us. We'd love to hear them. And again, Tom, thank you so much for being here. I really, really, truly appreciate it.
Sure. And if anybody, by the time you get this up, the Urantia Foundation should have all those talks from the scientific symposium. Mine will be one of them. So it can, supplement that even further. So, well, thank you, Josh. I've just really appreciated being here and talking to you and seeing you. You're my good friend, close up, and we're going to have many, many, many more times together from here to eternity. And it's just a blessing to know you now, because we got forever to be friends.
Yes, sir. I appreciate that. Well, thank you so much. Thank you so much. All right. You have a great rest of your day. Bye-bye.
Bye-bye.